In 14-1, we're going to look at linear measure, and we will learn about the English system, the metric system, and conversion among the measures. We will also look at dimensional analysis, perimeter and circumference of two-dimensional figures, and the ratios of linear measures of similar figures. Now, 1 yard is equivalent to 3 feet, 1 foot is equivalent to 12 inches, and 1 mile is equivalent to 1,760 yards or 5,280 feet. This is an excellent table when we need to do conversion from different units in the English system. So let's try to convert 5.25 miles to yards. We'll write 5.25 miles first, and then in order to convert this to yards, I need to multiply it by a fraction. Now I want to cancel out the miles, so I know miles has to be in the denominator of the fraction. And I want to end up with yards, so I'm going to put yards on the top. Now we need to know how many yards there are per mile. So for that, we'll go to our table. From our table, we have 1 mile is equivalent to 1,760 yards. So we have 1,760 yards is equivalent to 1 mile. Now the reason we use this fraction is this is known as a units fraction. A units fraction. A units fraction is a fraction whose value is equal to 1. We know that 1 mile is equivalent to 1,760 yards, so this has a value of 1. Since I'm multiplying a value of 1 times 5.25 miles, it doesn't change the value of 5.25 miles. It actually changes the units, but the distance is the same. Notice that the miles cancel out, and we're left with yards at the end when we multiply across. So now all I have to do is multiply 5.25 times 1,760, and we will end up with yards as our final unit. And multiplying it out, we will have 9,240 yards. Now let's try to convert 5,478 feet to yards. I will start by writing 5,478 feet, and then I will need to multiply it by a unit fraction. For that, we'll go to our table, and from our table we have 1 yard is equivalent to 3 feet. So now how do I decide who goes on the top and who goes on the bottom? Well, I want to cancel out feet, so we'll put the feet on the bottom, and then we'll put the yards on the top. Now, we know that it has to be 1 yard over 3 feet, because this is our unit fraction. 1 yard is equivalent to 3 feet, so again we have a value of 1. The feet cancel out, and then we can multiply across. Multiplying across, we have 5,478 yards on the top, and on the bottom we just have a denominator of 3. Of course, we could simplify by dividing by 3, and that gives us 5,478 divided by 3 gives us 1,826 yards. So now we know that 5,478 feet is equivalent to 1,826 yards. If a cheetah is clocked at 60 miles per hour, what is the speed in feet per second? Here we're going to need multiple unit fractions. We'll start by writing 60 miles per hour as a fraction. So 60 miles over 1 hour is equivalent to saying 60 miles per hour. I'm going to multiply it by a unit fraction, and I'll start by canceling out the miles. I will put 1 mile on the bottom, and we'll go to our table to convert this to feet. From our table, 1 mile is equivalent to 5,280 feet. So the appropriate units fraction is 5,280 feet over 1 mile. Now, if I were to multiply this out, I would notice the miles would cancel out, but my answer would be feet per hour, and I'm looking for feet per second. So we'll still need another unit fraction, this time to cancel out the hours. Since the hours is on the bottom, I'll need the hours on the top, and I want to convert to seconds, but before I convert to seconds, I'll convert it to minutes first. I know 1 hour is equivalent to 60 minutes, and then I want to cancel out the minutes, so we'll put the minutes on the top, and in the denominator we want seconds. And of course 1 minute is 60 seconds. Now let's check to make sure our units are proper at the end. The miles will cancel out, the hour would cancel out, the minutes will cancel out, and so we have feet over second, so feet per second, we know the units are done correctly. So let's just multiply the top. We have 60 times 5,280 feet times 1, so we don't need to mention those numbers on the right, over 1 times 60 times 60. So we'll just write 60 times 60 in the denominator. We have 60 times 60, and the units for the denominator is in seconds. Notice the 60 on the top divides out with one of the 60s on the bottom. Now we can divide 5,280 by 60, and that gives us 88 feet over a second. So this is equivalent to 88 feet per second. Let's look at the metric system now. The meter is the base unit for the metric system. Every other unit always refers to the base unit. For example, the decameter requires 10 meters to equal 1 decameter. For a hectometer, we need 100 meters, and for a kilometer, we need 1,000 meters. For a decimeter, it will be equivalent to 1/10 of a meter. For a centimeter, it will be equivalent to 1/100th of a meter. And for a millimeter, it would be equivalent to 1/1000th of a meter. So this is an excellent table to use when you're converting from metric system to metric system. Now let's try converting metric units. The nice thing about metric units is the base is base 10. And that makes it easy to convert from the units. All we have to do is move the decimal place the corresponding position that we need. So let's look at this chart and we'll figure out how to use it when converting units. Part A, we want to convert 1.4 kilometers to meters. So I'm going from kilometers to meters. Using the chart, we want to go from kilometers to our base unit, meters. So we need to move 1, 2, 3. I need to move our decimal place 3 times to the right to get to our base unit. So this is equivalent to moving the decimal 3 times to the right. 1, 2, 3. And that gives us 1400. So 1,400 meters is equivalent to 1.4 kilometers. In B, I want to convert from millimeters to meters. So we'll go look at the chart for that. I want to go from millimeter to meter, which is our base unit. So I'm going to have to move 1, 2, 3 spaces to the left, and that will give us our answer. The decimal place is on the right side of the 5, and we'll move it 3 places to the left. 1, 2, 3. So we get 0.285 meters is equivalent to 285 millimeters. For part C, I want to convert from kilometer to centimeters. So we'll go look at our chart for that as well. So I'm going from kilometers to millimeters. So we need to move it 1, 2, 3, 4, 5, 6 times to the right to convert from kilometer to meters. So this will be moved 6 times to the right. 1, 2, 3, 4, 5, 6. And here's our new decimal point. So we have 3. And I'll add a 0 for each of these valleys. 1, 2, 3, 4 valleys. So we know 0.03 kilometers is equivalent to 30,000 centimeters. So converting with metric units is fairly simple. We just got to know which way to move the decimal place. And for that, always refer back to the table. The triangle inequality. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Here we have a generic triangle, and if I take the length of AB and add that with BC, that sum must always be greater than the third side, AC. Can a triangle be made with sides that are 15 centimeters, 18 centimeters, and 37 centimeters? The answer is no. Because if I take 15 centimeters and add that with 18 centimeters, the sum is 33 centimeters, and that is not greater than 37 centimeters. So by the triangle inequality, this cannot be possible. So a triangle cannot be made with these side lengths. The perimeter of an object is the length of a simple closed curve, or the sum of the lengths of the sides of a polygon. Let's find the perimeter of each of the shapes. We are simply adding the distance around the object. So we'll add 3 centimeters plus 3 centimeters plus 3 centimeters. So the perimeter for the first figure is going to be 9 centimeters, the distance around the object. For the second object, we have the distance here is L. So we'll add L plus the distance W plus another distance L, and finally the last distance is W. And of course this could be simplified to the formula for the perimeter of a rectangle, which is 2L plus 2W. Let's find the perimeter of this first figure here. The perimeter is the sum of all the sides, and since this is a square, because all of the side lengths are the same, and we have a right corner, the perimeter of a square is going to be 4s. For the second figure, a common mistake would be to add up all of the distances before looking at the units. If we look at the units, some of them are in meters and some of them are in centimeters. So we'll need to convert to a common unit of measurement. I'm going to choose to convert from centimeters to millimeters. 3 centimeters is equivalent to 30 millimeters. 1 centimeter is equivalent to 10 millimeters. And 3 centimeters is, of course, 30 millimeters. Now, to find the perimeter, we just have to add up all of the sides with the same units. So we have the perimeter is equal to 30 millimeters plus 10 millimeters plus 30 millimeters plus 40 millimeters plus the 60 millimeters, and that gives us 170 millimeters. So be careful, make sure you convert to the same units before you add up all of the sides. A circle is the set of all points in a plane that are the same distance from a given point, the center. The circumference is the perimeter of a circle, or the distance around the circle. Pi is the ratio between the circumference of a circle and the length of its diameter. The pi symbol can be found using your calculator. It's approximately 3.14, but it's an irrational number that keeps going on forever. The formula for circumference is equal to 2 pi r, where r is the radius. The arc length is equal to pi r theta divided by 180 degrees. And again, theta is our interior angle. Again, theta is our interior angle. Find each of the following. Part A, the circumference of a circle with radius 2 meters. The circumference of a circle is given by 2 pi r, so we'll plug in the radius of 2 meters. So the circumference is equal to 2 pi, and we'll plug in the radius, which is 2 meters. And that gives us 4 pi meters. And that gives us 4 pi meters. Part B, we want to find the radius of a circle with a circumference of 15 pi meters. We know the formula for the circumference of a circle again is 2 pi r. So we'll plug in the circumference, which is given as 15 pi meters. And we don't know what the radius is, so we'll leave it as r. As you can see, we could divide both sides by 2 pi. We'll divide both sides by 2 pi. Notice that the 2 pi and the 2 pi will divide out on the right. And on the left side, the pi's will divide out, leaving us 15 over 2. So the radius is 15 over 2 meters. Or we can write the radius is equal to 7.5 meters. For part C, we want to find the length of a 25-degree arc of a circle with diameter 10 centimeters. We know the formula for the arc length is L equals pi r theta divided by 180. In the problem, we know that theta is 25 degrees and the diameter is 10 centimeters. Since the diameter is 10 centimeters, we know the radius is going to be half of that, so the radius must be 5 centimeters. And now we can plug in the values for the formula. So we'll plug in the values for the formula. We have pi, the radius is 5 centimeters. Theta is 25 degrees, and we'll divide that by 180. The 5 and the 180 reduce to give us 25 over 36 pi, and our units is still centimeters, so our answer is 25 over 36 pi centimeters. In part D, we want to find the radius of an arc whose central angle is 87 degrees and whose arc length is 154 centimeters. We know the formula for arc length is L is equal to pi r theta divided by 180. The length is given as 154 centimeters. That's equal to pi times the radius, which we don't know, and theta is 87 degrees. We'll multiply both sides by 180 to cancel out the denominator. (180) times 154 is 27,720, and we have the units is still centimeters. This is equal to 87 pi r. And now I can get rid of the 87 pi by dividing both sides by 87 pi. If we divide both sides by 87 pi, we have the radius is equivalent to, approximately 101.4 centimeters.